And this is the third and final section of the final exam review. Which of the following pHs indicates a basic solution? Again, acid on the pH scale. Acid is less than 7, base is greater than 7. So we need something that's bigger than 7. The only choice here bigger than 7 is 12. What is the name of this acid? Okay, so anytime you have an acid compound with an O in it, it's not going to have hydro in front. Okay, so that's the first thing. So something like HCl doesn't have an oxygen. We call it hydrochloric acid. And so you put the hydro in front of it if it doesn't have oxygen. This one has oxygen, which means it's got a polyatomic ion in it. The polyatomic ion, NO3 negative, is called nitrate. If it was NO2, that would be called nitrite. Okay, you'll have a list of the polyatomic ions, so you will be able to look up NO2, NO3, SO4, all those polyatomic ions to find the names. Here's the key part. Sorry, two key parts. The first key part, as I already said, if it's got oxygen, it doesn't have hydro. Okay, so that eliminates those choices. The other part is the decision between nitrous or nitric has to do with the ending of the name of the polyatomic ion. Anything that ends in ATE becomes IC or IC. So that tells us this is going to be nitric acid. If it ends in ITE, it becomes OUS, or it would be nitrous. So HNO2 would be nitrous acid, but that's not what we have. We have HNO3, which is nitrate, which we turn into nitric. That's the name. And what type of acid is HNO3? You have to look up, there's a handful of acids that are called strong acids and a handful of strong acids that are called weak acids. And you need to look up what the strong acids are. There's only a few of them. Nitric acid happens to be what's classified as a strong acid. Strong acid means that it dissociates or ionizes completely. Okay, so every single molecule of this dissolves or dissociates in water. So dissociates completely equals strong. Dissociates partially equals weak. Okay, this is not one of those. Okay, so classifying the types of reactions. In the first one, we have two reactants. We have one product. So that follows the general formula of A plus B produces AB. Anytime you have multiple reactants and a single product, that's going to be called synthesis or combination, but we usually use synthesis. The second choice, we have one reactant, more than one product. So that's the opposite of synthesis. Okay, the opposite of synthesis is called decomposition, something breaking apart. Decomposition is AB produces A plus B. So one reactant, multiple products is called decomposition. In this next one, we have two compounds on the left and two compounds on the right, but they're different combinations. So we have effectively AB plus CD gives us AD plus CB. That's called a double replacement reaction or double displacement. Either way is fine. In the last one, we have a compound and an element, and on the other side we have a different compound and a different element, or some of the elements have traded places. So that's AB plus C gives us CB plus A. Okay, because the A and the CA have, or sorry, the AG and the CA have traded places. Well, that's also displacement. That one's called single displacement. And the only one that's not on here is combustion, which is usually similar to a synthesis reaction, but not always. The key is a combustion reaction will always have O2 as one of the reactants. Balancing equations. So again, in balancing equations, what you're looking for is you want to make sure you've got the same number of each thing on both sides. And I can't touch the little numbers at the bottom. All I can do is put big numbers in front of any of the substances I want. Just remembering that if I put a number in front of part of a compound, it applies to the whole compound. So if I can't just double the the sodium in this compound without doubling the oxygen, they go together. So you can only do compounds in a group. All right. So in the first one, I've got 2 sodiums, Na2, and 1 oxygen on the left. I've got 1 sodium and 2 oxygens on the right, so they're kind of reversed. Well, I can't lower the number of sodiums on the left, which means I'm going to have to increase the number of sodiums on the right. I can't lower the number of oxygens on the right, but I got to increase the number on the left. So the first thing I'm going to do, and usually leave elements to the end, leave things like water to the end. I've only got elements on the right-hand side, so I can't leave one or the other. But since I know that I'm going to have to increase the oxygen, I'm going to start with that. So I have 2 oxygens on the right, which means if I put a 2 in front of this, that gives me 2 oxygens on the left. That also means 2 times 2, 4 sodiums. Now if I put a 4 here, I've got 4 sodiums on the left, 4 sodiums on the right. I've got 2 oxygens on the left, 2 oxygens on the right. In the second one, I've got 3 different elements in a couple different places, different combinations. The key thing to look at here is the oxygens on either side. One's an even number, one's an odd number. I got to fix that because I can't break up the oxygens the way they are. So I have to make them both even numbers because I can never make an even number an odd number. And so what I have to do is figure out what's the smallest number that 4 and 3 will both go into. Well, it's 12, right? So 3 times 4 oxygens is 12. 4 times 3 oxygens is 12 on the right. So there's 12 on the left, 12 on the right. Now I've got to look at the other elements. Well, I did 3 here, which means there's 9 manganese on the left. So I put a 9 over here. That takes care of that. And I put a 4 in front of this. 4 times 2 is 8, so I've got to put an 8 there to balance out the aluminums. So that takes care of that. So 3, 8, 4, and 9 are the coefficients that balance those equations. What are the molar masses of these compounds? And you've got to look at the periodic table to find the mass of each element in the compound. And then if there are subscripts, little numbers like this, you multiply the mass of that element by the subscript. And then you add it all up. So in the first one, I've got copper, which has a mass of 63.5, plus sulfur, which has a mass of 32, plus oxygen, which has a mass of 16, but since there's a little number 4, it's 16 times 4. The little numbers, when they're just next to an element, only multiply the element right in front of them. So 4 only goes to the oxygen, not to the sulfur or the copper. So 63.5 plus 32 plus 16 times 4 gives me 159.5 grams per mole. In the second one, I've got aluminum, which is 27 grams. And then when you have a subscript outside of parentheses, just like in math, the number outside the parentheses distributes to everything inside the parentheses. So the 3 here, because of the parentheses, applies to the oxygen and the hydrogen. So I've got oxygen, which is 16 times the 3, and then I've got hydrogen, which is 1 times the 3. Add all that up, and we're going to get 78 grams per mole for that. And the last one is magnesium, which has a mass of 24.3. And then here we've got a number outside the parentheses and a number inside the parentheses, which means the 2 is going to multiply times the nitrogen. So the nitrogen is 14. The 2 goes to that. And then we've also got oxygen, which is 16 times 3. And outside the parentheses, there's a 2. So 16 times 3 times 2, or 16 times 6. And so when we do that out, we get 24.3 plus 28 plus 96, which is 150.3 grams per mole. Okay, and the last one is a percent error calculation. Percent error is take the accepted or correct value, accepted, and then you subtract your value, your experimental or what you actually get in the lab. You divide that by the accepted value, and then you multiply by 100 to make it a percentage. So we plug in the numbers, and it's 36.1 minus 31.5 divided by 36.1 times 100, which would equal 12.7% error. All right, that is the last problem on the review. I will be showing you in class the reference sheet that you will get and what you'll be given as part of the test, like the periodic table and formulas and things like that, that will be given to you. And then obviously anything else is up to you to know. So you'll get that in class. And any questions you have, go through these problems, go through this video, and then we can go over any final questions you have in class.